Alright, class, the last unit of Chapter 4, we're going to be solving systems of inequalities. And before we do that, I'm going to recap the methods that we used for solving systems of equations. The first of which was graphing, and it might seem easy. It does give you the concept of the answer to a system is a point of intersection, like right here, but sometimes, as we learned it in the last section, the graphing sometimes lets us down, and if we're going to make use of it consistently, then perhaps we need a graphing calculator. So when it comes to these three methods, graphing, substitution, and elimination, I'm not that pleased with graphing, and I kind of just leave it alone and just go with one of these two. Now, the substitution and elimination, I usually ask the students, which one they like better, and I usually get the answer substitution until I remind them of elimination and substitution, and they tend to think that they remember substitution the most, but elimination was the one they liked the most. So the substitution and elimination methods tend to be preferred, whereas the graphing not so much, because sometimes it could be problematic and we just don't know if it's going to be before we start the problem. So we tend to just avoid it. Well, that's actually going to change for systems of inequality. There's one method, and as you can guess from the graph here, we're going to solve it by graphing. And why is that? Well, I'm going to show you in just a second, but back here, remember that when we solve systems of equations, the answer was a point of intersection. And sometimes it was 2 points of intersection, like if you had a parabola and a line, and they managed to intersect at 2 points, there were two solutions, two unique different solutions to that system. But for something like this, there's going to be multiple, and I'm going to show you. Alright, so let's see. I'm not going to solve this using the intercepts method because this number 4 isn't divisible by that number 3. So I'm going to use what most of you typically use, and that's solve this for y and use y equals mx plus b. Okay, but it's not equals, it is less than, so we're going to have to deal with that. Alright, so we're going to isolate the y. So the first thing we're going to do is subtract 3x from both sides. So I'm going to have, after the first step, 2y is less than negative 3x plus 4. And then I divide everything by 2. So I get y is less than negative 3 halves x plus 2. Now that's like, but not exactly, it's like y equals negative 3 halves x plus 2. Before we start graphing it though, this is a non-inclusive inequality sign, so it's going to be dotted. So I'm not going to make a solid line. Y-intercept at 2. And then it has a slope that rises 3 and runs 2, and it's a negative slope, so it goes up to the left. I can't make another point up there that's going to show the 3-to-2 ratio. So here's another one, and one final point. And then we're just going to make a dotted line. Now this is called the boundary line. On the boundary line, it shows where it goes up to, and if there was the inclusive sign, what it goes up to and what is equal to. But then we have the rest of the answer. Now it's less than. Okay, less than. So less than is going to be here. If I took the time and filled this in perfectly, which I guess I could with a pen as big as this highlighter that I have here, all the points that are highlighted, and even if I manage to leave some gaps, those two, those are all solutions. Now, what this shape is called, and I don't mean to cross that line, but I'm not going to undo that. What this shape is called, it's a shaded half plane. You probably don't need to know that, but just realize that our answer isn't this particular shape. I mean, it actually continues over here, goes up here, goes down here, and is over here. So I just stopped where the grid line stopped, but the actual shading doesn't. So there are infinitely many solutions, there are solutions here and here and here and here and here and here, everywhere where there's yellow. So the that boundary line that's dotted and the shaded region below, that's our answer. So back to the different methods we had for solving systems of equations, graphing was the one that was not preferred, and these two were the preferred methods. But that's not going to be the case for inequalities, because graphing is the only method, because I have infinitely many points, and it's much easier to describe them with the picture than with the with equations or sentences or whatever you would do to describe this. So that's what we're going to be doing. So here's another one. Y greater than or equal to -1. Now that has the inclusive sign, so we are going to have a solid boundary line. Y equals some number is a horizontal line, so we're going to go down here to -1 and make a solid line. Oh, didn't notice this right off the bat, but there is a big difference between the last one and this one. We're talking about systems, right? And systems are more than one equation, more than one equality. And I didn't show you a system here, I just showed you one inequality. So how's this going to be different? It's going to be the overlapping of shading. Alright, now notice in this one here, everything's negative. Let's multiply everything by a -1. Now, you don't have to do that, but if you did do that, I'm multiplying by a negative or dividing by a negative, so you have to flip that inequality sign. I notice that people are forgetting that rule. Subtract x from both sides. So I have 2y is greater than -x plus 4. Divide by 2. Y is greater than -1/2 x plus 2. Think about that slope. That's a -1 right there. Even though there's no -1 written, you divide by 2. It's -1/2. So we have, let's see, y-intercept at 2, and slope up 1 over 2. Let's put some more points in there. Now, if this were a system of equations, this point right here would have been the answer. But it's not. It's a system of inequalities. Okay, so y is greater than or equal to -1. Let me get a highlighter here. As thick as possible. And y greater than or equal to -1, so that would be this region here. Now, right now, I'm completely ignoring that that red line, and it's a dotted red line too. And I'll fill it in a little bit later, or fill it in better a little bit later. Now I'm going to change highlighters. Let's see. Now, notice this original sign points this direction, and you'd be like, oh, it's less than, but you have to realize that when you divided by the negative, the sign flipped, so you're thinking greater than, and greater than is above for y. See, right here, greater than, that's all you could see is above. Greater than this line is right here. Notice how it's green. Now it's yellow. Alright, so this is kind of the yellow and blue makes green color philosophy. Probably a fact that you guys know. Pretty common fact. So the answer is the overlapping, which is kind of neat to see with actual colors in this electronic device. That the answer is this shaded region here. And let's see, let's just go back to a color and get a nice thick pen so I can just outline this for you. It's dotted. And then it's solid, and then it goes infinitely far this way, and it goes infinitely far this way, and it's all of this. So that's typically how you would draw it on your graph paper. You're not going to take highlighters. You're just going to, you could if you wanted to, but you're just going to take your pencil and you're going to shade. Oh, best doing this in pencil, by the way. Maybe I should put that at the beginning of the video. Alright, now notice that these have the same A and B terms. This would be my A and this would be my B. It may not be something you remember, but a standard linear form is AX plus BY equals C. Now I know that we're not dealing with equals here, but kind of the same deal. A is 2, B is 4. A is 2, B is 4. Since those are the same numbers, these are going to be parallel lines. And before, whenever we had parallel lines and it was systems, we had no solution. That's not going to happen here. I'm going to solve these in just 1 second, and you're just going to see it appear. Okay, so here's what I'm getting when I'm solving these. I took the top one here, and its solution is down here. Subtract 2x from both sides, divide by 4. Notice that I'm not leaving the slope as -2/4. I'm going to simplify that and make it -2, or sorry, -1/2. The sign doesn't flip. I didn't multiply or divide by a negative. And the second one, I kind of just went, here's how it's going to look. We're going to have the same slope, but we're going to have a different y-intercept. So they are not going to intersect those lines, but the shaded region still could. And I get something like this. Now I really should fill those in because those are the inclusive sign. So give me a second here. This boundary line will be solid, and this boundary line will also be solid. Now the one on the bottom is this one, and its y is greater than, so it is shaded above. So it would be all this, above that purple line. And then the next one, blue, it's going to be less than this equation that had the y-intercept of 3. So it's this, and remember that the intersection of the two is the answer, so right here. Now, I guess I might not have been too clear here. Just give me a second to clean this up. When you actually give me the answer to this, I'm just going to make a rough sketch over here. You're going to show me this boundary line and this boundary line, and final answer could simply be like this. Now this will all be over here. You don't necessarily have to show me both sets of shading and the overlap, but I do have some students that will go, alright, well I'm going to shade this one like this, and I'm going to shade this one like this, and the one that has like the cross hatch is the area that is the answer. With the colors, it's kind of cool. The yellow and blue make green thing. You can see the green is the answer, and I can kind of stick with that. But you don't have that technology. You just have your pen and pencil to shade with. So something like this is perfectly fine.